Okay. Oh, the larynx. So I did say I'd come back to this. So the larynx has several cartilages, and for some reason I forgot to take those out of the. Oops, that's one of the ones I wanted. Sorry. This will match with your lab activity, the edited one. That's the cartilage I want you to know. It's just the thyroid. The rest of them are interesting, intricate cartilages, but no, you don't have to know all of them. So the thyroid specifically is this one. It's kind of like a big plate, actually kind of two plates. In the midlines here, and one plate goes this way, and the other plate goes this way, that protect we'll get to in a minute, your vocal cords or vocal ligaments that are just posterior to them. And actually, this thyroid cartilage is open in the back, so this is the anterior. And in the posterior, you'll see these are the two plates of thyroid cartilage, and they don't make a complete ring, but they do a great job of protecting it in the anterior. Also, the larynx has, these would be what are commonly called vocal cords, but really technically they are what we call ligaments. And folds because you fold a mucous membrane layer over them. So where are these? I'm actually going to start at the bottom list. Oh, actually I could start with the cartilage. So this is, to orient, a superior view. And here is your thyroid cartilage right there. And this is where the two plates join right on the midline. So posterior to that are these set of ligaments. So the vocal ligaments are here. They are the ones that are more medial. And when they have some mucous membrane folded over them, kind of like if you had it attached here and it folded over that ligament and came back, that is the vocal fold. So they would look like this down here. So actually these two lighter ones there, those are the vocal folds. And then there's also what we call the false vocal cords. So those are right here, the set of ligaments that are a little more lateral. And the fold, because they have mucous membrane folded over them as well. Let's do this. There we go. There's the two vestibular folds. So we sometimes call those the false vocal cords because they're very similar place and structure, but they cannot produce sound. So we should just talk briefly about how you make sound with these vocal ligaments. So erase all this. This is the position you would be in. Notice that, forgot to point this out, this is also a superior view, but this time the ligaments have been swiveled away. So those would be the two vocal ligaments. Those are the two vestibular. So which position are you in when you're talking? I usually ask students, and often I get this is the answer, as a possible guess. And in fact, it's not that. It's this one. When those vocal folds are closer to each other, that's when you can produce sound. So what happens is they get very close together, but they don't quite touch, these two vocal folds right here. And then air will rush past them at high pressure. And these vocal folds are literally wave like that, so maybe they're a flat when you're not speaking. And then when the air rushes past them, it makes them. This is really similar to what happens when you pluck a guitar string. So you pluck the string and it goes, vibrates back and forth, and that's what produces a sound. So basically your vocal folds are very similar. These things will, oscillate, move back and forth, and that produces a sound. Now, the false vocal cords, which are here, or false vocal folds, really, the vestibular folds, they are not close enough to each other, and the air won't rush past them at high speeds and make them move back and forth. So they cannot produce sound. So these structures, the folds, the ligaments, the folds, the cartilages, they did not evolve originally for sound production. Actually, they evolved to protect the airway. Every time you swallow, this thing closes off completely to protect you from getting food or other foreign objects down into your airway. So you can actually close this completely. You won't make any sound. You'll just close it. And so an easy way to do this really quick is just hold your breath. Take in a breath. Hold it. You have, when you're holding it, completely closed off your airway using your vocal folds. And then, when you release it, you can release it, say, at high pressure. That's a cough. When you cough, you inhale, you hold it, and you kind of squeeze your lungs, with all those muscles around it, like the intercostals. You squeeze your lungs, and then the air comes out. Very high pressure when you let go, and then a cough will come out. Once you do, in fact, let go of those vocal folds. Okay, so respiratory portion is the very, very, very end of your respiratory tract. And alveolar sac actually refers to this whole bundle of grapes. It's not just one individual one, because I used to think that as well. These individual little bubbles here, those are the alveoli. That's plural, and just in case you ever see this, alveolus is singular. That would be one single bubble. So a whole bunch of them like this, I think it looks like a bunch of grapes with this little stem here. That is the sac. You have to have a whole like grape bundle there of alveoli. Okay, so the alveoli is where your gas exchange is actually taking place. And then, well, let's see, we got that alveoli, pulmonary capillaries. So you notice that a couple of these alveoli here are surrounded by a net of capillaries, and actually all of them would be in life. So here's a question. Which vessel is this? This blue one. It's a branch of what vessel that we already learned? You got to be thinking pulmonary because it's going to the lungs. The pulmonary what? If you're tempted to say vein, that makes sense because it's blue. It's actually a pulmonary artery or a branch of the pulmonary artery because it's switched. The colors are switched, or the oxygenation, I should say, is switched in the lungs versus everywhere else. So, the right ventricle pumped this blood in this artery, and then it'll come and it will exchange gas here. And then once it has the oxygen, it's going to be red. And then it'll eventually all the branches lead into this. Red. This is a pulmonary vein. So remember, colors are switched here. Okay. What kind of cells in the walls of, well, not just the sac, the individual alveoli as well. What are they made of? So when I say types of cells on the walls, I actually should say, that make up the walls of your alveoli and ultimately your alveolar sacs. So type 1, alveolar type 1 cell, sometimes also called squamous alveolar cell, is it's actually cells that make up a simple squamous epithelium. They wouldn't be arranged like, in a row, in a line. Actually be arranged, in a sphere. Ultimately, I only can draw in 2 dimensions. Those flat cells make up, they're like, I think, tiles on a wall. That's what makes up your alveoli. So this is the most common cell type. And then alveolar type 2, sometimes also called a septic cell. So these guys, they secrete this interesting substance called surfactant. And surfactant, I'll give you the short answer. The surfactant, reduces surface tension between air and water. So, and water likes to stick to itself, and it does not, get along well with air, actually. So water tends to want to form droplets, round droplets, because that is the maximum volume that it can have with, this amount of surface area. So I should rephrase that. Minimizes surface area. That's what this spherical shape does. And that's what water will do, is it'll tend to be in droplets. And the reason for that is, well, it's polar. So just really quick, oxygen, 2 hydrogens, H2O. The oxygen side is a little bit more negative a little more positive, and the hydrogen side, a little more negative. So when you get a bunch of these molecules together, what tends to happen is you'll get another oxygen next door to that one, and a couple H's, then maybe another oxygen here attached to that H, and then has its own H's, one of which is attached to this one. So water likes to stick to itself because it has all of these positive, negative bonds, really. It's just, we call it cohesive. So surfactant will, break up those molecules a little bit more. So you don't have this surface tension that tends to want to be a ball. This is really important because, back up for a sec. So in this instance, oh, I should just do where the capillaries are. You see all the capillaries there? These individual alveoli are surrounded by water. And they're surrounded by a ring of water, kind of like this, with nothing in the middle. And the water is going to want to stick together. It's going to have this urge to form a droplet. And if that were to happen, your alveoli collapse, you can't breathe. Because you remember that the alveoli have air in them, and they're surrounded by blood, which is, a lot of it is water. So to deal with this problem of surface tension, this substance will decrease it. And actually, oops, you use it every day, probably, hopefully. That's basically what soap does. You may notice that soapy water feels more filmy. It's like it sticks to you better in some ways. That's because soap reduces the surface tension between air and water. So pulmonary surfactant is important. Also, quick aside, when they say that, an individual is born premature, their lungs aren't fully developed, one of the issues is they're not making surfactant. So their lungs, the alveoli could be collapsing. So fortunately, I don't know when this finally came out, but there is an artificial surfactant apparently that, you can have the little baby inhale that will take care of that until these type 2 cells are mature. Last type of cell, macrophages. Hopefully you remember this means big. And this means eater, sometimes also called dust cells. And these guys will just clean up whatever debris has made it all the way to the alveoli. And in Salt Lake City, unfortunately, a fair amount does. So our macrophages are probably working overtime.